Have you ever stopped to wonder how an electric guitar, a solid plank of wood with some wires, can create a sound powerful enough to fill a stadium? Unlike an acoustic guitar with its large, hollow body designed to naturally amplify string vibrations, a solid-body electric guitar is almost silent on its own. So, what's the secret? It's not magic, but it is a fascinating journey involving physics, magnetism, electricity. This process transforms a simple physical action, plucking a string, into a complex and expressive musical voice. It's a beautiful chain reaction, a perfect marriage of mechanics and electronics that gave birth to rock and roll, blues, metal, and so much more. Think about it, a silent object brought to life by a hidden force. Let's start at the very beginning. When you pluck a guitar string, it vibrates. This is the origin of everything that follows. The string moves back and forth hundreds of times per second. The speed of this vibration determines the pitch of the note you hear. A faster vibration creates a higher pitch, while a slower one produces a lower pitch. On an acoustic guitar, this vibration moves the air inside the guitar's body, which then projects the sound. But on an electric guitar, this physical vibration is just the first, almost inaudible step in a much more intricate process that happens under the surface. The pickups are the heart of the electric guitar. If you look closely at them, you'll see small dots, which are the tops of tiny magnets called pole pieces. One for each string. These magnets are wrapped in thousands of turns of ultrafine copper wire, creating a coil. Together, the magnet and the coil create a stable, invisible magnetic field that extends upwards and surrounds the steel strings. Nothing is happening yet, the system is just waiting for you to play. This magnetic field is the key. It's a silent potential energy field, patiently waiting for a disturbance. Can you picture it? A bubble of magnetic force just sitting there, right under the strings. Now let's bring back our vibrating steel string. When the string moves back and forth through this magnetic field, it causes a disturbance. Michael Faraday, 1830s. A changing magnetic field passing through a coil will induce a tiny electrical current. As your string vibrates, it alters the shape and intensity of the magnetic field around it. That fluctuation generates alternating current in the pickup's copper coil. The frequency of the string's vibration directly matches the electrical frequency. High note makes a high-frequency current. A low note makes a low-frequency one. The electrical signal is extremely weak at this stage. It's a faint, fragile representation of your playing, but it's incredibly detailed, capturing pitch and dynamics. Pluck hard. Wider vibration, bigger field disturbance, stronger signal. Every bend, every bit of vibrato, every subtle touch, all are captured and converted into electrical information. The pickup is essentially a microphone for magnetic disturbances, translating performance into a raw audio signal. Different pickups create different sounds. Now that we have this raw electrical signal from the pickups, where does it go? It doesn't travel directly to the output jack. First, it stops at the guitar's onboard electronics. Volume knobs, tone knobs, pickup selector switch. This is your control room, where you shape that raw signal. The pickup selector switch is the most straightforward. It chooses which pickup or combination is active. Bright bridge pickup, warmer neck pickup, in-between combined pickups. This choice alone changes your tone. The volume knob is more than simple loudness control. Technically, it doesn't add volume, it subtracts signal. On 10, it passes 100% of the pickup signal. Turn it down. The potentiometer increases resistance and bleeds signal to ground. That bleed can make the tone darker or less brilliant. Experiment with the volume knob for dynamics. The tone knob is a bit mysterious. It's essentially a filter. Inside, the tone knob connects to a capacitor. A capacitor stores and releases energy and favors high frequencies. Turn the tone down. The capacitor bleeds highs to ground. Result, bright edges smoothed. Warmer, darker sound, like turning down treble on a stereo, but at the source. Using selector, volume, and tone gives you huge control over sound. Bitey, aggressive bridge with tone full, smooth, mellow neck with tone rolled back, no amp change. The electric guitar is deeply expressive for this reason. Understanding these controls is the first step to mastering your instrument's voice. Our sculpted electrical signal has now passed through the control room and reached the output jack. We plug in a cable. That tiny current travels down the wire to the amplifier. The amp's job is simple. Take a weak guitar signal and make it thousands of times stronger. It does this in two stages. First, the signal enters the preamp, where it's boosted and shaped by EQ, bass, middle, treble. Often gain or distortion is added here. Gain is critical. Push preamp tubes in a tube amp or circuitry in a solid-state amp, and you begin to clip the signal. The waveform stops being smooth, the peaks get flattened, that clipping becomes distortion or overdrive, the rock crunch. This is the biggest difference from an acoustic. We don't just make it louder, we change the waveform to create new textures and harmonics. After the preamp, the shaped signal goes to the power amp. Power amp equals pure muscle. It supplies power, voltage, and current to move the speaker. Final critical energy conversion, electrical to physical. The power amp makes the air vibrate so we can hear the sound. Finally, the signal reaches the speaker. Speaker equals transducer opposite the pickup. It has a